Okay, so we're going to start on Descartes' rule of signs. It's on page 200 of section 4.6, and it's more of just kind of a check, a way to check yourself. So the book has a pretty good example. I'm going to do monitoring 10, and I'm going to show you how to do this using a chart. So first we're going to take a look at the polynomial. We're going to count the number of sign changes, and what I mean by that is that positive to negative, negative to positive, right? We're going to count that. That gives you the possible number of positive real roots. Then, instead of x, we're going to substitute it for negative x. We're going to do the math, then we're going to count it again, the number of changes. And that gives you the possible number of negative roots. And then from there, we can also figure out what's the possible number of imaginary roots, knowing the total. So, here we go. Okay, so let's count the number of changes first. So, positive to negative, that's 1. Negative to positive, that's 2. It's 3, 4. So there are 4 changes here. That means the possible number of positive roots is going to be 4. Now, how many total zeros are there going to be? We know from the degree that there's always going to be a total of 4. So that means that if there is 4 possible positive real roots, and the total has to be 4, how many negative real roots could there be? None. How many imaginary real roots can there be? None. Alright, so now we're going to plug in for negative x. 3 negative, negative x to the 4th minus 7 negative x cubed plus negative x squared minus 13 times negative x plus 8. Alright, to the 4th power it's always going to be positive. To the 3rd power is going to be negative, but it's also negative 7 here, so that's going to be positive. To the 2nd power even, it's going to be positive. Negative 13 and negative x is going to be positive, and then positive. Alright, we've now done step 2. We've substituted for negative x. We've done the math. Now let's count the changes. Positive to positive, no change, no change, no change, no change. Okay, there's no changes. So if there's no changes, how many possible negative real roots can we have? Well, we could have 0. Alright, so if you remember, I said that there is 0 changes here from signs to positive and negative, which means there's 0 number of real roots. Now, if you also remember, imaginary zeros have to come in pairs because of the conjugate theorem. So, if there is 0 negative, and let's just say that there are 2 imaginary because it comes in pairs, that means there's a possibility of having 2 positive because there has to be a total of 4. And the last one is, if there is 0 negative roots, imaginary roots come in pairs, so it could be 2 imaginary or it could be 4 imaginary, which means positive roots, there's going to be 0, again, for a total of 4. Now, this is just a guess and check. When you get your answers, these are the only possible combinations of roots that you can get.